Proof that sequence un be defined by u1 equals to root 2, un plus 1 equals to root over 2 un for all n greater than equals to 1 converges to 2. और इस सीक्वेंस को हम ऐसे भी लिख सकते हैं, फर्स्ट एलिमेंट रूट 2 u1 u2 here u1 it put n equals to 1, that means 1 plus 1 equals to root over 2 u1 u2 equals to u1 means root 2. So second element root over 2 root 2. Third u3 equals to, again using this 2 u2 equals to root over 2 u2 means this 2 into root 2. So we can write this sequence, same question. Prove that the sequence this converges to 2 or this. So first u n plus 1 square equals to 2 un. So u n square equals to 2 u n minus 1, we can write. Now subtract u n plus 1 square minus u n square equals to 2 u n minus 2 u n minus 1. That means u n plus 1 plus u n into u n plus 1 minus u n formula equals to 2 common, then u n minus u n minus 1. Now since un strictly greater than 0 for all n, because u1 root 2 u2 root over 2 into root 2, so all strictly greater than 0. Therefore this must be greater than 0, strictly greater than 0. So we get un plus 1 minus un. We don't know sequence un is monotonically increasing or decreasing. So here un plus 1 minus un greater than or less than 0 according as un minus un minus 1 greater than or less than 0, because this is strictly greater than 0, so this will be greater than or less than 0 according as this will be greater than, this is greater than 0 or less than 0. Therefore un plus 1 greater than or less than un according as un greater than or less than un minus 1. Now since u1 equals to root 2, this is strictly less than 2 root 2, and 2 root 2 means root over 2 root 2 means u2, because root 2 obviously less than root over 2 into some multiply root 2. So u1 less than u2. Therefore from using this, here n equals to 2, we put n equals to 2 in this. Therefore we get here u1 less than u2, that means u2 greater than u1. So this will be u2 plus 1, that means u3 greater than u2, because this greater than or less than this according as un greater than or less than un minus 1. Now here u1 less than u2, so according this u3 greater than u2. So u1 less than u2, and continuing this process we get u3 less than u4 less than dot, dot, dot. Therefore the sequence un is strictly monotonically increasing. We repeat this again, u1 less than u2 from this. So here put n equals to 2, then we get here u2 greater than u1. So this will be u2 plus 1 means u3 greater than u2. So similarly from this u3 greater than u2 we get u4 greater than u3 using this, because u4 greater than u3 according as u3 greater than u2. So we get u1, and continuing this process we get u1 less than u2 less than u3 less than u4 less than so on. Therefore the sequence un is strictly monotonically increasing. So we get un plus 1 greater than un, because sequence un is strictly monotonically increasing. Therefore un plus 1 square greater than un square implies now un plus 1 equals to root over 2un. So un plus 1 square equals to 2un. 2un greater than un square implies 0 greater than un. un square minus 2un implies un into un minus 2 less than 0. Since un greater than 0 for all n, therefore this is greater than 0 for all n, therefore this must be less than 0, because un into un minus 2 less than 0. Therefore un minus 2 less than 0 for all n implies un less than 2 for all n. This shows that the sequence un is bounded above. Therefore sequence un is monotonically increasing and bounded above. Hence we know if a sequence is monotonically increasing and bounded above, then the sequence is convergent. Hence sequence un is convergent. Let limit n tends to infinity un equals to L. Then un plus 1 square equals to 2un. Implies limit n tends to infinity un plus 1 square equals to limit n tends to infinity 2un. This implies limit, this can be written as limit n tends to infinity un plus 1 whole square equals to 2 into limit n tends to infinity un. Now limit n tends to un equals to L. Therefore we can also say limit n tends to infinity un plus 1 equals to L. So L square equals to 2L implies L square minus 2L equals to 0 implies L into L minus 2 equals to 0. Since u1 equals to root 2 and sequence un is monotonically increasing, therefore this sequence cannot converge to 0. That means so L does not equal to 0, because u1 first element root and sequence un is monotonically increasing. That means we are left with L minus 2 equals to 0. This means therefore L minus 2 equals to 0 implies L equals to 2. So sequence UN converges to 2. Proved. If you like this video, please share and subscribe.